Good afternoon. I am Mariusz Dąbrowski, the president of Jerzy Stelmach Eureka Foundation. During this week, we are organizing the discussion session entitled Extraterrestrial Life and Civilizations, Where and How to Search for Them. We are under the project which is co-financed by the Polish Ministry of Science and Higher Education under the Social Responsibility of Science 2 program. And the idea is to bring some achievements of outstanding scientists to the general public. Our session is held in English and Polish. Today we have the debate, which is in English. It will be translated into Polish and made available to the audience in a couple of days. But today we are going to discuss some next problems related to the communication of the alien civilizations, and the exact title of the discussion is what astronomical equipment can serve to contact extraterrestrial civilizations. I invited for our discussion today our main lecturer from Wednesday, Professor Paul Davies. Hello, Paul.
Hello.
And also a local professor from the cosmology group of the University of Szczecin, Professor Vincenzo Zalzano. Hello, Vincenzo.
Hello, welcome.
Okay, let us start our discussion. The discussion today is gonna to be devoted to the equipment, to the forms of contact between us and civilizations. But we needed some equipment to do so. I have my handy antenna here, which is kind of a funny device, which I will talk more about later. But anyway, I would like to ask first the question to Professor Davies. What types of communications, of means of communications with aliens we really have, I would like to put it in the context of the fundamental physics, because in the fundamental physics we have four interactions, fundamental interactions: nuclear, strong and weak. They are short range, so not very much benefit in applying perhaps them to the contact with extraterrestrial civilizations, and also the long range interactions, which are electromagnetic and gravitational. And my question is, what is your opinion about the means of communication, whether we can use only these types of interactions to communicate with some other civilizations, or are there any other options? Maybe Professor Paul Davies first, please.
Well, I think for our audience, we should explain some basic physics. And one of these is that we physicists really don't think that any means of sending information faster than light is possible. We may discover new physics in the future, but at the moment, our best understanding is that we are restricted to the speed of light. And obviously, light goes at the speed of light, so do gravitational waves. And so almost at the speed of light, neutrinos, which are actually a product of the weak interaction. So that's the first point. Traditional SETI, the Search for Extraterrestrial Intelligence, has taken place using mainly radio, that is sweeping the skies with radio telescopes in the hope of picking up a radio signal. But increasingly the use of light as well, on the basis of laser communication. So that's optical SETI, that's often called. So that's the general point. There's another really important point of basic physics that I would like to get across. There is a popular misconception that quantum mechanics, and in particular the property of quantum mechanics called entanglement, which leads to a type of sort of telepathy between separated particles, could be used for instantaneous communication. That's completely wrong. That there are powerful theorems and our best understanding from experimental theory, quantum mechanics, you cannot use quantum entanglement to send messages faster than light. So let's not go down that path. And having said all that, and then I will stop talking, I'm a great advocate that we don't need to communicate with extraterrestrial civilizations to discover that they may be out there. We merely need what is these days called a techno-signature. That is, we need evidence that there is some technology out there in the universe that is not a human product. And if we found such technology, and it could vary from something like large-scale astro-engineering around some distant star, something that looked artificial, to an artifact within the solar system. It could be anywhere on that spectrum. It's non-human technology. We would immediately know we are not alone in the universe. We don't actually have to communicate to draw that profound conclusion.
Yeah, but this kind of refers to some kind of intermediate step, because the communication is kind of a higher level. We will have an evidence for having some extraterrestrial technology, but not necessarily the communication. Okay, I will switch if Vincenzo Zalzano wants to add something to this question related to these two interactions and usage of these two interactions.
Yeah. Well, the first thing which I have to say is a personal thing, because you know very well I'm a cosmologist, and although I don't work on this topic, I'm how to say in English, I guess it's aficionado. I have to say that I decided to study the universe, cosmology, astronomy, astrophysics, watching a movie which was about this. The name is Contact, and it was based on a book written by Carl Sagan, a very famous astronomer, American astronomer. He was very good in divulgation. And in this movie, there is a lot of science, also science fiction, and he was imagining how they could communicate. And I will say this because it's the funny part of this movie, but it still is the main method which is used today by us. By us, I mean, basically, in my mind, there is SETI, the SETI Institute, all the people working for SETI Institute. You in the movie, and nowadays still, most of this research is done using radio waves. And in this movie, it's funny because they catch a signal which has very specific properties. Maybe later we can specify why we use radio waves and how we think there should be a message inside. And they start to see that these signal radio waves have something encoded inside. And they start to analyze it, and they find they are able to reconstruct that there are some frames of images. They compose the images, and they find that it is are images from a movie which was broadcasted in 1936 during German Olympics. And there is the image of Hitler talking, making a speech. So immediately the people in the room freeze, and there are military entering because they say, now science stops. Here we enter now. Now we start to enter. It's funny because you have to put in the context. Although the movie, I guess, it was from the middle 90s, but the book was much earlier, from the 80s. And but this is how I still think that for sure we try to communicate, we not to communicate, to detect using radio waves. Maybe searching for some signal inside, and the reason is because radio waves are maybe the people who are listening, they know that radio waves are like cruises of light. They are waves, but the only difference is that these waves are much broader, much less energy and much broader. And this is important because it means, as Professor Davies said, they are like light. So the fastest signal can travel at that velocity, and radio waves are the fastest. Then there is another peculiarity respect to other kind of light, like visible light or ultraviolet, is that they can pass very easily through obstacles like dust and whatever, which is something which in other ranges of the electromagnetic wave, this cannot happen. So we have chosen this because radio waves are exactly tuned to travel undisturbed for long distances. And there is also another curiosity, because of course the people who started to have this idea to look for intelligent life in a scientific way, they had to start from something, no? And I'm thinking now about Drake and collaborators and so on. And one very specific, between today and tomorrow, there will be a lot of things which look like coincidences, but they are just physics. The most abundant element in the universe is hydrogen. Mm-hmm. And nowadays, based on our knowledge, we think that one of the most important elements for life, to sustain life, is water. Now, the coincidence, which is brought by physics, is that the emission lines of hydrogen and of the hydroxyl molecule, which is the other part of the water molecule, they emit, when excited, they emit exactly in the range of the radio waves, microwaves more or less, which is, it seems to be a coincidence that exactly the range of hydrogen, which is the most abundant element in the universe, is falling in that part of the electromagnetic wave spectrum. And the first explorers said, if there is another intelligent life in the universe, let us imagine that they are intelligent, they are able to have a knowledge of the space and nature and physics like us, where they could send signals. And they thought maybe they also know that hydrogen is the most abundant element in the universe. And they also know about quantum mechanics and whatever. And they could, if they had the same feeling of us to communicate or to search for another intelligent life, they could decide that the best place in which to send a signal is exactly in the radio wave, in these frequencies, which I discovered in these days, is called water hole. And it's called water hole for two reasons. First, because of the frequencies of hydrogen and hydroxyl, and also because I didn't know this, but water hole is used also in English and American, because it's when you are in a desert and you have some water, all life starts to concentrate there. And this is the same idea. We have this range in radio waves, which we use nowadays, which is probably it could be the range where the signals of other kind of intelligent life could send some message or whatever.
Okay, so maybe because I want to focus on the question, so the merit of the question is, which is kind of related to SETI, that not all the current astronomical equipment can be used for detection of the alien civilizations. Only those which are related to radio waves. This is your claim, yes?
There are also gravitational waves. Personally, I would exclude because the gravitational waves which we can detect nowadays
No, but
can be produced.
I'm talking about electromagnetic band. So
Radio
out of
waves.
electromagnetic, you say that radio waves are kind of more suitable. Paul, do you agree or
No, I don't agree because, as I mentioned earlier, there is a vigorous optical SETI program that looks for laser flashes from extraterrestrial civilizations. And then I should also make the point that, of course, the atmosphere does exclude certain wavelengths of radio waves. But ambitious SETI proponents look to a time when we can do this in space. And in particular, the most ambitious would be to have a radio telescope on the far side of the moon. And because it's possible now to cover a vast number of radio channels simultaneously, like 1,000,000,001 Hertz channels simultaneously, and analyze all that data, it's possible really to cover, well, from the moon, you could cover the entire electromagnetic spectrum. That's at this stage a very distant dream, the idea of putting equipment on the far side of the moon. But we could imagine doing that sometime later this century.
Okay, gravitational waves were mentioned already. Now, my question is, yes, we have detected gravitational waves, but they are extremely weak. So can we make any use of gravitational waves in detecting this extraterrestrial technology? And another question is, can we or can aliens send us the signal in terms of gravitational waves? Yeah, who first? Paul, maybe. Yeah.
Well, it's very expensive because, as you mentioned, gravity is extremely weak force, which means you need enormous amounts of energy to generate a very feeble gravitational wave. So it doesn't make a lot of sense as far as we can understand it. There's a curious idea that people have discussed over the years, which is, could you do the gravitational equivalent of a laser? In other words, you get some sort of huge amplification. Well, that takes us into the realm of the quantum theory of gravity, quantum gravity. And that's a theory which is not yet very well developed. It's people have worked on it, I have, over decades. But if we finally got a theory where we could talk about gravitons, just like where you can talk about photons, we had equipment that could manipulate gravitons, we might imagine that some future quantum gravity device might make something like a gravitational laser, and then that would change the game considerably. But the sort of gravitational waves being detected at LIGO and the other gravitational wave observatories represent enormous amounts of energy because, for example, it's the merger of two monster black holes that are producing these gravitational waves. And so we're not going to be doing that ourselves, and I don't see the aliens. It would be a very inefficient way of communicating to manipulate black holes to make them collide.
Vincenzo, how about you? What do you think? You agree?
Yeah. I agree. And if it is possible, yes. but possible, not probable, because as Professor Davies said, nowadays we have instruments to detect gravitational waves from merging of black holes or neutron stars. So there are two options. Or this civilization is able to manage these black holes and create signal on purpose, or, and it's not even easier, they are able to detect and they are able to maybe modulate them, modulate a signal in them which propagates. But I think that this is really, considering the nature of gravitational waves, is quite hard.
Okay, let me then make kind of a, claim or reference. There is something which is called a Kardashev scale of the energy level for extraterrestrial civilizations. So first level is the level of the Earth, which is in terms of the thousands of gigawatt, which is exactly what we are now about to producing around the whole Earth. And then there is the scale of the solar system. So the aliens can handle the energy which is comparable with the energy which is emitted by the sun. And then the third level is that they can handle an energy scale which is similar to the galaxy energy. So I think this, at least third level, they could easily be able to send some or make some kind of, I don't know, signal out of the neutron stars or something like this. What do you think about it? Maybe Paul. Yeah.
One of the reasons that this whole subject is such fun is to be able to speculate about, extreme scenarios in the far future, civilizations that have been around for millions of years, what could they achieve? But specifically about the Kardashev scale, I think one insight that I've had over the years interested in this subject is that when we talk about it, we tend to bring in the cultural connections of our time. And Kardashev lived at a time when industrial production and what a nation could achieve was very much measured in terms of its energy output, how many tons of coal you could burn or nuclear reactors and so on. And that was, nations were racing to do that. But then that changed a bit. And today we would say, well, a nation's prowess, if that word is understood, would be measured more in terms of its computational power, not its energy power. In other words,
but isn't the computational power related with the produced energy? Because in order to gain the computational power, you still need some energy to actually
well, you
support.
do, yes. But if we're being futuristic, in principle, you can process information for virtually zero. You could have, when you look at the thermodynamic limits of computation, it's possible, and certainly when it comes to quantum computing, the power output of the computation itself is effectively zero. So I only mention that because we may be missing what is actually the relevant limiting factor. It may not be energy, may not be computational power, it may be something else that our society hasn't yet discovered. And the difficulty about any of this speculation with SETI is that it's always based on our own species experience. What could we do and what might we do in the future? That's all we've got to go on. But I enjoy trying to think outside that box, to say, maybe there's a type of technology that doesn't fit into any of the categories we've been talking about. And then the problem is to guess what it might be. What do we look for? What type of technology might exist? And the science fiction writer Arthur C. Clarke said that sufficiently advanced technology would be indistinguishable from magic. So we look out into the universe for magic, whatever that might be. And so I think we have to be as broadly thinking as possible and to look for anything. There's this expression in English, if something looks fishy, you say, well, that looks fishy. It means it looks like another expression is a put-up job. That it looks like there's some manipulation, that there's something a bit suspicious about it. It's not a natural or random occurrence. So we look for anything fishy and be completely open-minded about the nature of the technology that underpins it.
I have a by-side question still maybe to Paul. How about having, because you excluded some superluminal communication with the aliens, of course, on the base of our theories, maybe in the future we will learn about. But how about another fundamental interaction like fifth or sixth force, which could also be kind of a, is it nowadays excluded or do you have an idea if there is, or do you have an idea how it could look like or something like this? Because usually this fifth force still was related more to the short range, not long range interactions. So, and this would limit us as if it was the nuclear. Anything like that? No idea.
Well, of course, in physics, it pays to be completely open-minded about new forces or interactions that may have escaped our attention. And in some exotic theories that involve higher dimensions and so on, there is something like a fifth force. These ideas sort of come and go, they are fashionable or not. But in no case so far that it would be taken seriously would this fifth force enable faster than light communication. It might give you another mode, another channel of communication, but not breaking the light barrier. I should say, it's a good point to insert this comment, that if we can imagine an advanced civilization that a long time ago may have sent a probe to our solar system, and this probe might be dormant, and if we were to activate it and communicate maybe by radio, then we would be able to talk to the probe in real time, because we wouldn't have to worry about the huge delay, many, many years for radio waves to cross the galaxy. It would be right here on our doorstep. We shouldn't exclude that possibility, but it's very hard to know where to look for a dormant alien probe.
Vincenzo, how about your view of the Kardashev scale? Do you think it's reasonable?
Well, considering that it was created by Russian scientists during Cold War, we have to always put in the context why this idea of pointing to energy consumption and so on. I have to say that I was, because since when you told me about this, I was studying because I knew Kardashev scale, but I didn't know exactly how. And I discovered that actually Sagan found a way to calculate exactly which level of civilization we are. And we are not even one, because I calculated, I have the numbers here, because in 2023, the total world energy consumption was 183,000 terawatt hours. Terawatt means 1 followed by 12 zeros, which is equivalent to an average power consumption of 21 terawatts. If you translate in a Kardashev scale, our civilization is level 0.73. So we are not even at the first level.
But we are almost at the first level. Yes.
Almost, but in order to arrive to one, we should be able to produce and consume 5 orders of magnitude more of energy. So it's not something which is going to be realized soon. So this scale, I mean, it is interesting because is providing some information to, we as humans, we always try to catalog, put everything in boxes and make a catalog. But I don't know how much useful is in leading for a search of intelligent life.
Mm-hmm. Yeah, Kardashev was also writing papers in cosmology, I remember. So he was, yes, you immediately made me comment on the previous lecture, which was given by Joao Magueijo, and he actually mentioned Polish writer Stanisław Lem, who was writing these futuristic books, science fiction. And yeah, in that sense, as you said, also Lem was kind of, he was writing the books when the political system still was going on, and then later he completely stopped doing so. So maybe it's kind of related, but this gigantic kind of view of the world is, of course, reflects in Kardashev's approach. I agree. So in principle, yes, you are right. So let me switch into other things. Okay, there is this famous joke, which I was taught, Paul can confirm or not, I don't know. There was a famous joke which I once heard from, actually Michael Keller taught me this joke, that aliens are going to come and civilization, British people are going to host them, and they were discussing how to communicate them, and one of the guys actually said, okay, since they are more intelligent than us, so how about communicating them in English? Okay, so the laziest possible option. So maybe they know how to communicate us, rather than we have to make an effort communicating them. So what do you think, Paul, about all this? Or maybe we have to, I mean, because they may have radically different and much easier means of communicating us than even we could think of them.
Right. Well, I've had that joke too, and I'm sure there's a similar one going around in China that they would speak Chinese. But it does raise the whole question about how do you communicate with a truly alien mind or alien civilization. And I've always taken a point of view that you might expect a theoretical physicist to take, which is that if we are communicating with a civilization that shares our physics, that they're familiar with the laws of quantum mechanics and relativity and so on, which they would need to be to set up any sort of communication, then there is one thing that they and we will share inevitably, and that is a knowledge of the laws of physics. And so the most unambiguous communication that we can imagine would be something connected to those shared laws. And you're going to like my example, because you worked in this area yourself, Merit, which is that if you take the quantity called the fine structure constant, and this is, just to explain to our viewers, the fine structure constant is made up of the fundamental constants of physics, the universal charge on the electron, Planck's constant, and the speed of light. You can combine them to make a pure number, and it's roughly 1 divided by 137, deeply mysterious as to where this number comes from. It's one of the fundamental constants of physics. And of course, people want to know, does it perhaps change slightly over time? But to many significant figures, that number seems to be fixed. And that's a number that the aliens would know as well as us. And so if you take that number and express it in binary arithmetic, so there's no problem about what base you're using, and we transmit that number, or if we detected that number, it carries a huge amount of information, because it would tell the aliens that we understood quantum mechanics and relativity, that we'd reach that sort of level. of understanding of the world. And that would be the first step. And then, of course, there would have to be many exchanges back and forth before we would build up a vocabulary where discussions of things like sport and politics would have any meaning at all to a truly alien mind.
Okay, let me shift into one more question related to communication. How about if they communicating us from a different spatial dimension? For example, if they live kind of extra dimensions, so can they project this piece of information onto three-dimensional space, or like if they were five-dimensional or four-dimensional spatially? What do you think, Paul? Yeah.
Do you want us to take that one? Well, of course, when there are many theories in physics that involve additional dimensions, but in all these cases, we human beings, and indeed the universe that we observe, is stuck to three dimensions of space and one of time. It's often called a brain within this higher dimensional theory. And we can imagine physics in the higher dimensions. And I suppose we could imagine that a very advanced civilization might be able to manipulate in these higher dimensions, but it would sort of imprint itself, so to speak, just in our three-dimensional space. Exactly how that would happen and whether that could somehow get around this faster than light restriction, I don't know, because it depends on the actual high dimensional theory. We have to be very careful, I think, in discussing things like SETI and the possibility of faster than light travel, not to, first of all, not to close our minds to other possibilities, but then not to open our minds so much that, anybody's theory goes, and that we, therefore, just because there's a theory out there somewhere means we should take it seriously. I do think we have to have to try to approach this subject, which is already speculative enough, using the best understanding we have of fundamental physics. But one day we may go beyond that. There would be a problem, I have to say, if there is some means, extra dimensions or wormholes often get mentioned, or some other type of manipulation of space-time. If it did permit the equivalent of faster than light communication, then it also permits time travel. That is, it permits looping back into the past, which unleashes any number of paradoxes, which are very familiar to people who read science fiction. The joy of time travel stories is that they open all these weird paradoxes about going back and changing the past and meeting your younger self and so on. So the restriction, no faster than light communication, goes hand in hand with no time loops or closed time light curves, as we call it, no time travel into the past. We can travel into the future, that's no problem. Getting to the future quicker is part of standard relativity theory, but looping back into the past is not excluded by our best understanding of space-time and gravitation, but it would be open up a Pandora's box of paradoxes.
Okay, now let me switch to the question to Vincenzo, perhaps. There is this famous Drake's formula. Okay, to both of you, but I'm kind of wondered of this. There is the Drake formula, and I always remember that when I was a teenage in the 70s, there was a lot of discussions on the media and everywhere that, there are stars in the universe, but nobody has discovered any planets. So, in fact, the planets don't exist because there is no evidence. And Drake's formula somehow, then planets were discovered, and we know now that they are reality. But still about extra civilizations which could occupy these planets, we don't know yet. And Drake's formula is actually referring to the probability of having civilizations in the universe. Okay, even I understand that even if we have one, the probability is one. Okay, that there is. And I have a question because I have not heard there was a formula like Drake's formula for the probability of having extrasolar planets to be present in the universe. Don't you think that there was some contradiction, or there is some contradiction? And even before we discovered the planets, okay, the Drake's formula was present, and so on. What do you think about it? Wasn't it a contradiction, or
No, no, in this case, I would say no, it's not a contradiction because even if we had no evidence of the existence of other planets, it was clear how planets, more or less clear how planets should form, how stars should form. I mean, everybody knew that if there is a large mass of molecular gas start to collapse, and then there is a thermonuclear explosion which creates the star. But what happens to the matter around? They can collapse and cluster, not collapse, and create planets. So even if we didn't see at that time any extra solar planets, it was quite reasonable to expect that there were others. So
exactly, this is what I mean. That then, of course, it was reasonable. But I can remember a lot of. Okay, Paul, you are older than me, but I can remember as a teenage that there were look, there were lots of discussion. Okay, look, nobody saw the extrasolar planets, so it means that they don't exist. Okay, so this is what I mean in the context of now, because we are now shifted somehow onto the stage. Now we have the evidence for the planets, but still no evidence for extraterrestrial civilizations. So I can use the same argument you are talking about. Okay.
But from I would ask you from whom you heard this. I guess it was not an astronomer or cosmologist because I mean we have a lot of things which were theoretically proposed before they were seen. So I don't see any contradiction. Also, I will say that Drake first experiments and SETI, they wanted to search for signals of intelligent life. I think they were not even thinking or posing the problem of where this intelligent life would live. They started to search for this, but still, I don't think that maybe I'm biased because I was born and I have always lived in a world in which the possibility of extrasolar planets are an evidence. But although I'm not so, I mean, in the 90s I was a kid. But anyway, it's an extrapolation, let's say, which was not crazy at all. I would say. Then I don't know. Probably I'm missing something, but even Galileo Galilei, 400 years ago, he found the moons around Jupiter, and he said, "Look, there is something like moon and Earth also there." So.
No, but you are an expert in all these statistics, all these, probabilistic, okay, all these testing models, etc. So statistics is more important. And we didn't have any statistics for the planets before the discovery, okay? And so first example, first evidence made the probability 1. And I think we are at the same stage nowadays, because what we are speculating statistically is 0, because we don't have any.
No, personally, I think it's different. Mm-hmm. I don't know if I'm able to convey the idea, but to imagine that there should be other planets, so a certain step of physical processes which we know they are not only possible, they are probable in any place, is different from asking the question if there is intelligent life. I think they are totally different, in my opinion, because
Okay.
also because in order to arrive to intelligent life, there must be many more steps than for the formation of a planet around a star.
Yeah, I agree. But for Copernicus, for the people before Copernicus, the whole universe was just the solar system. Okay. So somehow, yeah, it was then the galaxy was the universe until 1920. Okay. And then the Hubble horizon. Now, okay. So let us maybe move smoothly to what I was talking about yesterday. Okay, that the universe was considered a solar system until Copernicus, then it extended into galaxy, and then it emerged that there were more galaxies than one galaxy. And then Hubble horizon. Now we think also that there can be even more space for the aliens if we take into account a possibility that there are some other universes in terms of the different physical laws, different physical constants, and so on and so on. So somehow the probability of having extraterrestrial civilization is even growing larger, because if there was just one solar system and then stars, the probability was just multiplied by a couple of planets. Then the galaxy, okay. Then we had lots of solar systems within, then more galaxies, etc. What do you think? Is it reasonable? So according to statistics, the probability should grow and grow. The more we think the universe large is, yeah, statistically. And, or maybe Paul can make a comment to that.
It's very straightforward. Before I answer that question, I should just mention that Frank Drake liked to say the absence of evidence is not the same as the evidence of absence. And I do think there's a big difference between planets and life, because 100 years ago, it was true that we didn't really understand how planets form. But when Frank Drake began this project, there's a pretty clear idea of how planets form, and the fact that stars were rotating fairly slowly sort of was indirect evidence that there were planets out there. So our understanding of planetary formation, even before extrasolar planets were found, was in a much better state than our understanding of the origin of life. We have no idea how non-life becomes life and what number to put in for that. This is the F sub L in Drake's equation. That's the limiting factor. That's the bottleneck. We don't know how to compute how, if life gets going, how likely it is to become intelligent and have technological civilizations. We don't know how to work that number out, but at least we know the process. It's called Darwinian evolution. We don't know the process that turned non-life into life. It might be a bizarre fluke that happens only once in the universe, or it might be something that is commonplace, and it's completely unknown. So we can't really proceed beyond that point. But there is a general mathematical point which addresses your question, which is if you have a big enough sample, big enough volume of space, of course there will be life out there somewhere. And by extension, there will be a duplicate of you and me as well. If you go far enough out, just if the universe is uniform and the laws of nature are uniform, in an infinite universe, anything that can happen will happen an infinite number of times. So we're absolutely assured, based on simple mathematics, that there will be life out there somewhere and civilizations out there somewhere, but they could be a stupendous, exponentially greater distance than even the age, so-called age of our universe. So we can go down that path of considering in principle in a big enough space. But I think when it comes to SETI, what we want to know is, can we communicate or at least get direct physical evidence that we're not alone? And if the nearest life form or intelligence civilization, is a million Hubble lengths away, well, then that's of no interest to people doing SETI.
Okay.
Can I add
Yes,
something?
yes,
Because
please,
as
yes.
I told you, I was studying after you told me about this. And the beauty of science is that even starting from these crazy ideas, like there is an intelligent life which wants to communicate, you can produce science, study things, and learn new things. So I found a paper, a scientific article, a serious one, in which the authors, what they have done is, let us assume that the only conditions for life, intelligent life, to develop are the ones which are related to Earth. So water, habitable zone, a star like the sun. And what they have done is to take basically Drake equation, but updating with all the things which we know now. They have done calculations. And I can tell you what are the results. They call it strong astrobiological Copernican principle, which means that life can only develop on planets like Earth, around stars like Sun, with water and so on. They have found numbers. So they have found that in a distance, because they had data only till a certain distance from us, there can be in our galaxy a maximum of 36 intelligent civilizations. But the problem is the following. They are so far from us that in order to get any contact with them, SETI should be listening for 6,000 years, because we need 3,000 years to arrive there and then come back here. Yeah. This is in the very strong. If they relax these options, and they only ask for bacteria, not intelligent, so they will never be able to communicate, we find that the possibility of colonies of bacteria is 10 billions. And if we could find, I don't know, they are called biosignatures, we could. So there is, as you can see, if we don't ask for intelligent life, you can have up to 10 billions of worlds, of bacteria worlds in the galaxy. If you ask for something like us, with the knowledge of how life has started here, what we know now, only actually there are, in physics, we don't give absolute numbers. We always give numbers plus errors, which gives you the uncertainty. And I gave you what is the average number, 36. But if you consider the error, the minimum number is 8. So in the full galaxies, in our full Milky Way, there could be a maximum of 8 civilizations which could communicate with us, but we should wait like 6,000 years. And as I say, this is a study which starts from physics, stellar mass function, evolution of stars, and many other things. So it's very serious and reasonable. And the numbers which you find are like
Can I just interject? Because these are just made up numbers, because, of course, we understand the physics part and the astronomy part really rather well. Come back to the fact we absolutely do not understand the origin of life, the probability that given an Earth-like planet, and you wait 1 billion years or something, what is the probability that life will emerge? That could be any number at all. We have no evidence that it's, we know somewhere between 0 and 1. But we cannot say. And so you can guess a number, but I don't know where that guess would come from. And so sometimes people will say, and Carl Sagan made this comment, that because life established itself on Earth fairly quickly after the Earth formed and became habitable, that therefore the origin of life must be a rather probable affair. Carl Sagan said, no sooner was the Earth ready for it than up it popped. But and that argument is partially correct. It's true that if life did form readily, we would expect it to occur quickly on Earth. But it's also, as Brandon Carter pointed out many years ago, consistent with the opposite conclusion, that life is exceedingly unlikely to occur. And the reason is that if life hadn't got going quickly on Earth, we wouldn't be having this conversation now, because in another 800 million years, the sun will boil the oceans and life on Earth would be impossible. So if you have a window, finite window of habitability, and on a planet that gets as far as intelligence, you need to get life going very quickly. And it may be that that's an exceedingly improbable thing. And of course, why are we witness to such a near miraculous event? Well, because we are the product of it. We have selected it because, of course, if there's only one planet in the universe that has life on it, no coincidence it's this one, because we're a product of that life. So I have to be very careful with this statistical reasoning.
Okay, coming back to the final discussion, I would like to ask in particular Paul, because you were a bit involved into that. Do you think that, I mean, this is an idea of us becoming aliens, in fact, which means that we will just occupy different planets in our solar system and also in our galaxy. So what do you think about these planned missions to the Mars? Are they going to be performed according to the schedule? I mean, around 2040, reaching first moon. Okay, this project to land on moon and then inhabit, and then Mars. And then what would be the time scale of occupying the nearest, say, galaxy, the nearest stars or solar systems within the galaxy here?
We're colonizing Mars is, clearly a possibility. It would be an expensive undertaking. I've long been a fan of the idea of one-way missions to Mars because that cuts the cost enormously. If you just are setting up a base there, people don't come back. I have lost track of the number of new American presidents who announce, you come into office and say, we are going to fund a mission to Mars. And the present administration exactly the same. I'm not holding my breath because it's been going on for decades and decades. We can do it. We have the technology to do it. Whether we've got the political will, I really don't know. I'm skeptical.
And how about occupying some other solar systems within the galaxy? How, I mean, technically now we are almost at no position to actually land on or send a mission to the nearest stars or something like this, I think, yeah.
Right. So it would take, with our current technology, tens of thousands of years really to get to the stars. The idea of colonizing planets that might be out there, it's very hard to see the motivation. So at the very least, you would either have to deep freeze your astronauts or simply send fertilized eggs or something and incubate them at the other end. If we did find that there are there's intelligent life out there and civilizations and so on, and we wanted to propagate our species or our culture, we could always send them our DNA, information about our DNA to reconstruct them, humans on this remote planet. So we would do it by sending the information to build a human being, hoping that the aliens might comply. And that's interesting because maybe as a final comment, I can mention that I was fascinated by this subject a long time ago when I was a student and then a postdoc, working with Fred Hoyle at Cambridge University. And Fred rather famously wrote a TV series called A for Andromeda, which starred Julie Christie. It was the first role she had, and nobody knew her name. She became a superstar in this BBC TV series, Ava Andromeda, and it was precisely this scenario in reverse, that the aliens send a message of how to construct one of their beings here on Earth, and then the rest, was just dramatic theatre.
Okay, thank you. Vincenzo, would you like to comment on that? On us becoming the aliens in the universe?
I'm quite sure no.
Okay.
Because I want to add that one of the variables which we cannot control, but it is considered in these studies, is the so-called self-destruction. So we should also add, okay, even if there was any civilization, are we sure that they are still alive, or they? So I think that no, we are not looking at our technology and our fondness for self-destruction. No, we are not going to colonize probably Mars, but I don't think that we are going to go beyond the solar system.
Okay, we are coming to the end. We have a comment rather than a question on a chat. So the reason we haven't encountered anyone in the universe could also be that we might be living in a simulation, with the observable universe being merely a projection created by the simulation's constructor. This is a rather dark possibility, but for now, we can't entirely rule it out either. What do you think, Paul?
Well, I've written about that myself in the context of, are we alone in the universe? Are we living in a simulation? And certainly from a logical point of view, we can't rule it out. And I often make the comment, a simulation, we might call it a fake universe. Fake universes are much cheaper to make than real universes. And so there's a well-known argument that the universe is big enough and long enough would give rise to civilizations that would be able to create fake universes. And then if you and I are just random observers of reality, it's overwhelmingly likely that we'll be in a fake universe, not a real one, just as a numbers game. So it's a lot of fun. I myself think that there is a flaw in this argument, because if this is a fake universe, then we're dealing with fake laws of physics as well. And then to use these fake laws of physics to reason that fake universes are possible seems like a circular reasoning. And so I'm a bit skeptical that we're living in a simulation. But a lot of my colleagues take it seriously.
Okay, thank you very much. Thank you very much for the discussion, very vivid today. Also answering the questions. To the people who are listening to us on Zoom and YouTube, I would like to mention that we still we'll have two debates tomorrow. One debate will be about the kind of evidence in inverted commas for the aliens visiting us on Earth, actually reported from the local astronomers here in Szczecin, and then later summarizing discussion in which we will be also discussing some psychological and theological aspects of aliens civilizations. So thank you very much, Paul. Thank you very much, Enzo, for joining us today. And to the audience, have a nice evening, and listen to us on our YouTube channel, which is the Eureka Foundation channel. Thank you, and have a nice evening. Bye-bye. Have a nice
evening. Thank you.
Bye.
Goodbye.
Bye-bye.